Hi all, and I'm making this short video because I got a really good question about the use of balancing equations, and it's really a complicated and multi-step question, and it's the kind of thing I could have worked through and done a bunch of versions in class with you, but how do I do it in this wonderful online world? So let's do a multi-step process together. It won't be a long video, but hopefully it'll have some value for each and every one of you in cracking all this idea of grams to moles to molecules to balancing equations. So the question I'm going to do is question number 3 in the grams to moles to molecules worksheet on Brightspace. And it's about when you take potassium metal and you chuck it into water, which is very exciting. It blows up. It produces big explosions. It's very exciting. And it also produces KOH and hydrogen gas. Oops, hydrogen gas. So when that happens, and by the way, this is why group 1 metals are called alkali metals, because they produce bases, right? So OH, hydroxide, is base. It makes your water basic while hydrogen gas goes away. Oh, and by the way, as you're reading chapter 6 for the quiz, lots of heat. It's exothermic. Delta H is a negative number, meaning heat is leaving. It's exothermic. Not the question, but interesting. So all the matter on Earth has to be accounted for. We can't have an equation with different numbers of atoms, different numbers of particles on each side, because matter is not created or destroyed. So I see immediately a problem because I have 3 H's on the right and 2 H's on the left, right? So 2 H's, 1, 2, 3 on this side. So we can't change molecules, so let's change the number of these molecules. So if I have 2 of those, 2 KOHs. So now I have 4 hydrogens on the right-hand side. Remember, there's like a fulcrum here, and 4 hydrogens here. So that's good. And I have 2 oxygens on the right and 2 oxygens on the left. That checks out. The only thing I've screwed up is I have 2 Ks on the right, K, and I only have 1 K over here. So I'm going to put a 2 here. So there is a balanced equation. It's 2, 2, 2, and 1. What is that balanced equation? It's a ratio. It's not a fixed number of atoms. It's a relationship. It's a ratio. It says that whatever the number of potassiums, you'll get that many KOHs, potassium hydroxides. If you have 2 potassiums, you get 1 hydrogen gas in moles. If I had 10 potassiums, I get 5 hydrogens, right? Because it's 2K make 1 H2, right? It's a 1/2. There's nothing fixed about this. It's a relationship, a ratio. So let's do this. Let's go to the question itself. So the question is, if I had, he checks his notes, 156 grams of potassium, how many grams of KOH would I make? Well, we know that the balanced equation is not true for grams, it's true for moles. So let's turn 156 grams of potassium into moles. So, sorry. Now, I'm going to make sure that grams are on the top and bottom. 39 is the molar mass of potassium. So grams are on the top and bottom, they cancel. I end up with an answer in moles. If you punch that into a calculator, you get 4. Funny how often that works out when we're taking a chemistry course. So we have 4 moles of potassium. We're not asked about potassium. We're asked about potassium hydroxide. What do we know? We know that 2K makes 2KOH. In other words, whatever the potassium moles is, the potassium hydroxide is the same. That's awesome because that means we have 4 moles of KOH, right? But we're not asked about moles of KOH, we're asked about grams. So we look on the periodic table, that's 39, and that's oxygen 16 and hydrogen's 1, and we add that up and we get 56 grams per 1 mole. So let's write it. We have moles in the KOH. Let's write it so moles cancel. 56 grams per 1 mole. Moles cancel. We're going to get an answer in grams. And when you do that math with a calculator, you get 224 grams. So think about that. All the problems here are versions of that. There's a really good Gwyn video where the textbook author, it's right below this video, the textbook author suggests a really complicated problem with ethanol. But is it complicated? It's a version of this. Remember the big ideas. The coefficients are ratios, grams to moles to get into the balanced equation, moles to moles for any other thing, moles to grams. Hopefully this helped. Let me know if I can be of any other service to you. I'm constantly going to try to help out. And remember that Friday, unfortunately, we take a quiz on all this. Thanks for your time.